Okay, this is Statistics, Math 1114. We're talking about section 1.1, and this is part 2 of that. All right, so the following types of polls are common examples of the voluntary response samples. We should always be suspicious of the data that we get from voluntary responses. So this is going to be like an internet poll where people who are online can decide whether or not to respond, mail-in polls, whether they want to reply, telephone calls. I don't know how many of you have gotten a phone call during dinner and they ask, can I ask you questions around, different political ideas or different whatever. So they do this in, newspapers or magazines. Sometimes they do it on radio. One of the big examples of this was, I forget what the name of the show was. It's like The Voice, where you could call in and, you could vote by calling in, and they would charge your phone so much for being able to vote for the person you want to stay on or to be moved forward into the next spot up. Anyway, so that's a case of people having their voluntary response. Here's another example of voluntary response. Nightline, which was a news, I don't know if it's even still around, but it's a news broadcast, tends to be fairly conservative. They asked viewers to call in with their opinion about whether the UN headquarters should remain in the United States. Viewers then decided for themselves whether or not to call in with their opinions. 67% of the 1,860 people that called in said the UN should be removed and moved out of the United States. In a separate independent survey, 500 respondents were randomly selected and surveyed. There's that key word, randomly. And so 38 of the group wanted the UN to move out of the United States. That's a huge difference, almost twice as much. I mean, it's pretty significant change there. Now, which one is going to be the more reliable? Believe it or not, it's going to be the 30, how many was it? The 500 respondents is going to give us the better evidence of what the population really wants. Those 186,000, sorry about that, volunteer respondents, that's skewed. That's people who wanted to make an opinion known. That's people who feel strongly about it. The NRA used this a lot in the past. They would get people all riled up saying, this legislator was trying to take away your gun rights or whatever. And so they would get everybody amped up and have them call in or write or, whatever. And what wound up happening is that their voice was disproportionately loud because many other people were like, it's a good idea, or it's not so bad an idea, or it's maybe not the best idea, but I don't care enough to call. So that's a case of, there's a couple of cases there of when the voluntary response can skew your information, can skew your results. Okay, so we're going to analyze. That's the next step. We're going to complete our preparation. We've got our context, our source, our sampling method. That's where we're going to analyze the data. We're going to graph, and you can do a couple of different kinds of graphs. One's going to be linear. One is going to be like a bell curve. See if there's how the population falls out. Whether something is skewed in one direction or another. So there's a whole lot of stuff that's going to go on there when we actually wind up graphing it. There's going to be probably more than one way we approach it. We're going to apply statistical methods. You do not have to have super strong computational skills, but you do have to be careful about paying attention both to the method and to the arithmetic that you're doing. Okay, so the math in this class isn't going to be overly difficult, but it is going to be important to getting the right answer. All right, So the last step is we're going to determine our statistical process involves conclusions, what we should do to develop an ability to distinguish between statistical significance and practical significance. All right, so we're going to talk real specifically here. Statistical significance is achieved when the likelihood of an event occurring is by chance is less than 5%. All right, so if you were to get 98 girls out of 100 random births, it's going to be statistically significant. With such a extreme outcome, it's not likely the result is from a random chance. They probably went to, they went through and they surveyed a bunch of moms that were in a daughter's mom and daughter club or something. So the chances of that 98 out of 100, that's pretty unlikely. Now, getting 52 girls out of the 100 births is not going to be statistically significant. No, it's not exactly 50%, but it's, it's close. It's not real far away. It's not unlikely that it could happen. Okay, practical significance. So it's possible for some treatment, for some information to tell us it's statistically significant, but it doesn't always translate into the practical. One of the biggest cases of that is the Atkins Diet. There are folks who were big fans of this. You didn't eat any carbohydrates, you ate only protein, and you did that for a long time and you would lose some weight. Well, and they found that statistically it was significant. It did work. People lost weight. It was statistically significant, and they were able to make a statement around that yes, in fact, it does work. But when you get down to the practical significance, when you start looking at what actually you gain or what you lose, I guess in the weight is 5 pounds. So while it's statistically significant, we can say for certain that yes, in fact, this diet does make a difference. In the practical realm, 5 pounds, not sure that, there's some people who would definitely take it, but the 5 pounds isn't going to make a huge difference for a lot of people. All right, so there's a case, there's kind of a bird's eye view of the practical versus the statistical. Here's another actual example. So they had ProCare Industries. They had a product named Gender Choice that supposedly increased the chance of a couple having a baby with a gender that they desired. In absence of any evidence of its effectiveness, the product was banned by the FDA because it was gross deception to the customer or of the customer. So in this case, they weren't saying it wasn't, it was helpful or it wasn't helpful or that it would cause problems. They said, no, you can't market it here because it's you're deceiving people because there's no evidence saying that that's true. Well, suppose the product that was tested with 10,000 couples, they wanted to have baby girls, and the result consisted of 5,200 baby girls exactly born out of that 10,000 births. So we wind up looking at that and we say, well, the likelihood of getting that exact value, that 5,200 out of 10,000 births, that's really unlikely. So you're going to have 3 1,000ths of 1% that this is going to happen just randomly. Okay, so it doesn't seem like this is a real likely thing to have happen just in general. All right. Now, so that's the statistical significance. The 52% rate of girls, while it's statistically significant, lacks the practical significance. 52% is only slightly above the 50%. Couples who are thinking about using this product should probably pass. And actually, they've done some little bit of figuring for us. the likelihood of a baby being a girl is about 48%. So 49%. So it's slightly more likely that you're going to wind up with a boy than a girl. But again, in the terms of 100, if you have 50-50 or if you have 49 and 51, those aren't big numbers to be different by. So we talked about that. All right. I'm going to stop here, and we're going to pick up on the analyzing the data and potential pitfalls.